Hey guys, it's Miss Delcambre. Today's September the 16th, and we're going to be doing a little overview of today's lesson. I haven't seen y'all since last Thursday because of BOY testing. Well, I haven't seen since last Thursday because of BOY testing and universal screening. Do make sure you check your emails to see if I sent out I would have sent mostly everybody an email if they had any missing work or if all their work's up to date. And for my homeroom, for those that still have their BOY or universal screening to take. So here's kind of an overview of what you need for today. You need your journal, glue, pencil, a highlighter, and 2.2 and 2.3 notes. We're going to basically glue in 2.3. We're not going to write on them or anything like that, but we will get back to it. So our overview is what our week's going to look like. And then our 2.1 review, we're going to go over a couple of numbers, see how we would categorize them. 2.2 and 2.3 notes, and then we'll check our homework. Your homework is only 9 through 15, and I'll probably do 9 and 10, so you just have about 5 left. So if you go to your Google Classroom, go to my classwork, go down to Google Slides. There's my Bitmoji Classroom that has the agenda on there. So when I click here, go to the second page, and it will show what our week is going to look like. I've already sent out your Builder 4. So Builder 4 was already sent out, and it's due on Friday, so hopefully you're working on that. So Monday and Tuesday, you did universal screening, and you did your BOY. So today we went over 2.1, continued that, then started on to 2.2 and 2.3. We touched on it. We're going to go more into depth on Thursday. Your homework tonight's 2.1, 9 through it's 15, not 14. Let me correct that right now. Oh, I typed 14 again. 15. There we go. And Builder 4. Your study guide is tomorrow's homework, but I already sent it out and had it available for today. So if you want to go ahead and get a jump start on that, you're more than welcome to. And then Friday, we'll do a review. I'm not sure about Kahoot. We may do a GIM kit on that day as a review. We'll just have to see about that. Okay, so our last thing that we talked about was rational numbers the other day. On Thursday, we talked about rational numbers. Now, rational numbers are those numbers that can be written as fractions. Okay, now remember that whole numbers can be written as a fraction because we just put a 1 under it. So I'm going to flip my page over here. So a whole number can be a fraction because I can make it have a denominator of 1 and it will work. Their opposites, which is any negative whole number, or integers are rational numbers because I can put a 1 in a denominator spot. Decimals are rational numbers because I look at place value. Place value, so that's 6/10, so 6 over 10, and bam, I made it a fraction. And any mixed number, improper fraction, or fraction in general is a fraction already, so it's a rational number automatically. Okay? Now, we talked about a little bit about irrational numbers. You'll talk more about that in 7th grade, but here's our example. So like 5 is a rational number because it can be written as a fraction, 5 over 1. It's an integer because it's a whole number or its opposite, or 0, and it's also a whole number. So 5, which is a whole number, falls into all 3 categories. So if I had the example of 2/3, okay? So 2/3 is written as a fraction already. So I know that it's a rational number. But it's not an integer. It's not a whole number or its opposite. So if I looked at my integer number line, 2/3 is nowhere located on it. So it's a rational number only. Okay? If I did -7.5, Negative 7.5. Well, negative 7.5 can be written as a fraction as 7 5/10, which would be 75 over 100. I'm sorry, 75 over 10, which does make it a fraction. So it is a rational number. But do I see it on my integer number line? Let's look. 7. No, it's not there. So it's a rational number only. Okay. Let's look at the number 0. Can 0 be made into a fraction? Yes, because I can put it as a denominator of 1. So this is a rational number. Is 0 an integer? Is it a whole number or its opposite? Well, let's see. Is it on my integer number line? Bam, there's 0. So 0 is an integer. Now, is 0 a whole number? Yes, 0 is a whole number. So we would count it as a whole number. Okay, just like our song. Natural numbers are naturally numbers that you count on your hands and your feet. 1, 2, 3, 4, and so on. Whole numbers are natural to including 0. So 0 is a whole number. It's not natural, okay? You won't be learning that. That's not one of those categories that will hit because you'll have to know the 3. These 3 natural numbers are ones that we will not be going into. But it's all whole numbers excluding 0. So it does not work there. All righty. So let's go to our notes for today. So it's 2.2, which is identifying opposites and absolute values of rational numbers. So you're going to glue that on the left side of the page, and the right side is going to be left blank. And then you can go ahead and glue in 2.3, turn the page, and glue in 2.3 on the left side, and leave the right side blank because we're going to be writing on here. Okay? So today is 9/16, so go ahead and date your work. I'm going to fix my camera right there so you can see it. All right, so to find the opposite of a rational number is the same way you find the opposite of an integer. 2 rational numbers are opposite if they have the same distance from 0, but on different sides of 0. Same way as I did with my integer. Actually, I can look and it's basically word for word. I can look. It's word for word. What are we looking for? We're looking for opposites. Same distance from 0, but on the different side of 0. Same distance from 0, but on different sides of 0. You see, exact wording, exactly like it was a couple of days ago. So here was my example, 2 3/4, and negative 2 3/4 are opposites because they're both 2 3/4 away from 0. So the opposite of 7 would be negative 7. The opposite of negative 3.5 would be a positive 3.5. The opposite of 2 25/100 would be a negative 2 25/100. And the opposite of 9 1/3 would be a negative 9 1/3. Okay? Now we're going into absolute value, which is the same thing as when we found with integers. We're going to go look back, exact same wording. So you can find the absolute value of a rational number the same way you can find the absolute value of an integer. The absolute value of a rational number is a number's distance away from 0 on a number line. Keyword there, guys, is distance. When you hear talking about distance away from 0, absolute value, absolute value. All right, and I can actually look back into absolute value, my notes here, and it says distance from 0 on a number line. The number's distance from 0 on a number line. So there is no change in the words. So the number's distance away from 0 on a number line. So we're going to graph each number on the number line here, and then to find its absolute value. Well, the one thing I like to do when I have a number line and it has some blanks is I like to fill in the empty spots. Okay, so it's at 0, 1, 2, 3, and 4, and 5 is given to us, and then I'm going to fill in the left side. So that's -1, -2, -3, -4. Okay, so I'm finding where -4.5 is. So -4.5 would be on the left side, and it's between -4 and -5. Kind of got cut off on printing, but that's a -5. So it's going to go right here. And this is -4.5. Okay. The distance away from 0, how many hops do I need to go from 0? So let's go 0 to this number. 1, 2, 3. 1, 2, 3, 4 spots, and then a half. So it's 4.5. All right, looking at the next one, 1.5. Well, 1.5 is located between 1 and 2, and it's directly in the middle there. So this is 1.5, and it's 1.5 away. So the absolute value is 1.5. Okay, number 6 here, the absolute value of 4. So I'm going to find 4 right there. And 4 is 1, 2, 3, 4 spots away from 0 on my number line. And now -3 and 1/4. Okay, so -3 and 1/4 is located between -3 and -4. However, it's not located in the middle. It's going to be closer to the 3 than it is in the middle or to the 4. So this would be -3 and 1/4. And it's 1, 2, 3, and 1/4 away. So the absolute value is 3 and 1/4. It's 3 and 1/4. So I want you to do this at the bottom. I want you to write a number, and I want you to write what its opposite is, and I want you to write what the absolute value is. And its opposite and absolute value of a number always the same? Not always. It depends on if you have a positive or a negative number that you're looking at. Okay? All right. Now, let's flip our page over. So key things I want you to take away from this is negative numbers opposites are always positive. I don't like using positive always when it deals with math, because there's sometimes it doesn't have it. However, in this situation, always will always work. Negative numbers or opposites are always going to be positive, and vice versa. And what I mean with vice versa, if you've never heard of that, that would mean the opposite. So positive numbers, opposites, are always negative. Are always negative. That's what I meant when I meant vice versa. So you're just switching it around. Okay. Now, tomorrow we're going to be dealing with this section, this ordering fractions and filling this whole thing out. So we're not going to touch this right now, but we're going to write some notes over on this side. And when we are comparing and ordering rational numbers, there are decimals, there are fractions, there's whole numbers, there's negatives, there's mixed numbers, there's improper fractions, all sorts of stuff. But when you start ordering these numbers, you want to make sure that they're all in the same format. You want to make sure that you're looking and you're not comparing decimals and fractions. You want to make sure that you're comparing all of the same together. So I like to do making all my fractions as decimals, because then I think of it like money and I compare it that way. Because everybody deals with money and everybody can compare money. So you're just looking basically at place value. So this is how we go from a fraction to a decimal. Okay, and you probably have heard this before. It's just to reiterate, T-I-B-O, TIBO. Top in, bottom out. Top in, bottom out. So what that means, if I have a fraction, move this down. I have the fraction 5/8. Okay. I'm going to do my little division hut right here. So top number goes in, bottom number goes out. So 8 is going to be out here. All right. So I can't take 8 away from 5, so I got to put a decimal and throw some zeros behind it. Okay. So I'm going to bring this decimal up. So 8 can't go into 5, but 8 can go into 50 6 times, because 6 times 8 gives me 48. And I'm left with 2 as remainder. I keep going, don't stop. So I'm going to bring down this 0. 8 can go into 20. Well, 8 times 2 gives me 16. That's close. 8 times 2 gives me 16. Then I'm left with 4. I know that I picked the right number because my remainder and my divisor, my remainder is smaller than my divisor. So I'm good, in good company right here. So then I'm going to bring down this 0 and I have 40. Well, 8 times 5 gives me 40 exactly. And I'm left with a remainder of 0. So you want to divide until you get to a remainder of 0. Or, I'm going to show you in a minute. So 5/8 and 625 thousandths is the exact same thing. So they have the exact same value. They have the exact same value. Okay, now, I said you want to get to a remainder of 0, or you want to get to where your quotient keeps going and it's the same number. You're getting a repeated decimal. And there's some examples. So I'm going to give you the example of 1/3. 1/3 is a repeated decimal, and I'm going to show you how. So top in, bottom out, still top in, 1, 3 outside. Okay, can't go into 1, so I'm going to throw some zeros behind there. And I'm going to bring that decimal up. Okay, but 3 can't go into 1. But 3 can go into 10 3 times, because 3 times 3 gives me 9. 10 minus 9 gives me 1. Okay, I have a remainder of 1. Bring down my 0 to make 10. 3 can go into 10 3 times. 3 times 3 gives me 9. 10 minus 9 gives me 1. Bring down my 0. Do you see how each and every time I'm getting a 1 as a remainder? It becomes a 10 when I bring down a 0. And I still am going to be multiplying 3 by 3 to give me 9. This is what we call a repeating decimal. So instead of keep going and going and going, if you see that your pattern starts, stop right there, throw a line over it, the 3, and then that tells people that that 3 keeps on continuing. That this is what we call a repeated decimal. A repeated decimal. Okay? So in some instances, you'll have fractions that when they turn into decimals, they'll repeat. They'll repeat. Okay, but then you stop like after the third one. Okay, now this is very important because I want you to understand that there is multiple ways to show division. So we're going to write 4 ways to show division. So ways to show division. Okay, so remember we did top in, bottom out. So I'm going to use this 5/8 like I did the last one. So 5/8. Okay, that's a way, as a fraction, that's a way to show division. Hold on for 1 second. Okay, sorry, the screen froze on me. So 5/8. Well, we knew that 5 inside the house, 8 outside the house is another way to show division. So this is a way to show division. Top in, bottom out is another way, just like this in our division hut, how we solve it. This is another way. 5 with the symbol, the division symbol, the little dot, line, dot, divided by 8. So 5 first, 8 last. First, last. First in, last out. Okay? If you look closely at the division symbol right here, you can see it kind of looks like this fraction. It has a line in the middle, and if you put a number here, it shows division. So you can think of fractions are another form of division. So the last one that we're going to do now, you may see this sometimes like in Brain Pop on the computer, maybe on iExcel or on Prodigy, and you may see it like this. Okay, you may see it with this line, and that's just because maybe the computer program couldn't make this, or couldn't make it look like this, or couldn't make it look like this. So this would be the fourth way to show division. Okay, and it just is like a little fraction line that's on that they couldn't make on the keyboard, that they used on the keyboard. All right. So that is it for our notes. I'm going to minimize the screen right now, and then I'm going to bring up our homework. So minimize, and our homework for tonight, as I said, the module study guide is up. So it's like 20 something questions. So if you want to go ahead and get working on that and get a head start, you're more than welcome to. Some of the numbers, like, hey, what's -2 and its opposite? Find it on a number line. Which statement is true? You have some multiple choice here. Which number is furthest from 0 on a number line? So some of this stuff is easy that you can go ahead and get going already and get doing. But some of it you may want to hold off until tomorrow. So that's the homework that will be given. I mean, that has gone out, but we'll need it for Friday. So tonight's homework is classifying rational numbers. All right. So you will not be doing 1 through 8. Okay, 1 through 8 you're not going to do. I just want you to focus right here on this 9 through 15. So I said I was going to do 2, and I'll do 2. So we have -13. All right. So -13 can be written as a fraction by making it having a denominator of 1. So I know it's a rational number. Is it an integer? Is it on my integer number line? If I looked, yes, it is. It is on my integer number line. So it went through 2 spots so far. Let's see if it will be a whole number. Is -13 a whole number? No, it is not. It's not a whole number. So I'm going to come over here and I'm going to annotate with Cami. And I'm coming to get a text box. Guys, all we're doing is typing. You don't need to draw anything like that. So give it one moment. So I'm going to come over here. I'm going to get my text box. I like to do a different color just because it will pop. So this would be a rational number and an integer. Okay. So looking at my next number, I have 1/6. Well, 1/6, can it be made into a fraction? It's already a fraction, so I already know it's a rational number. Well, is 1/6 an integer? It's not. It's not a whole number. It's not an opposite, and it's not 0. So 1/6 would be a rational number. And then I can, since you see how I didn't put it on the line, I can move it around so it pops up there. Okay? So that's how you will annotate with Cami on this worksheet. All you're doing is just typing your answers right there. So be careful, look back into your notes of which number and which category or categories it will fall into. All right, I hope you have a great day, and I will see you tomorrow. Bye.